Hey everyone, Joel here with Dissecting DIY, and today I want to go over electrical outlets and how to seal them. Electrical outlets are a bypass, and they can be a major source of heat loss or cold air loss straight into the attic space. So we want to try and seal these up as best we can to avoid losing our heated air to the outside, especially on exterior walls. It is also a great time when you're doing this to make sure that the electrical connections on the outlet are tight, secure, and there are some problems that you can actually run into if you're going to be messing around with these outlets. I don't look at them so much as problems as finding them. And the reason I say that is, say someone that put the electrical outlet in was not very savvy. Some of the connections cannot be in the right area, so the wire wants to go clockwise to the screw tightening, or it should go clockwise. So when you're tightening that screw, it tends to pull the wire in as opposed to push it out. It creates a better connection. You want to check for that. And then secondly, you want to make sure that those screws are tight enough that over time they're not going to get loose and start arcing. Now, I run into some outlets where as I'm pulling them out, some wires will come apart. They just weren't they weren't put together very well. And you just want to check for that. If you don't know what you're doing around electrical, please just stay away from it. You can do what I'm recommending, but I don't recommend pulling the outlet out. And of course, always shut the power off no matter what. You're going to be using some caulking around the box when we take this off. And that caulking is wet. You got to wait till it dries. And you got to also make sure that if any excess does get into the box itself, that you remove it. And you want to make it as clean as possible, and you just really want to stop the airflow from entering the wall cavity in certain places. Now, of course, caulking around where the sheetrock meets the electrical box, it's not going to do a whole lot unless there's other factors involved. And that's where we're going to use a press and seal gasket. Those are the ones I prefer. They have a motto: if it sticks, it seals. And I believe in that. I like that idea that there is a sticky backing to it that you attach to the wall plate itself, and then you push it on there a little thick. And you're not using foam to get R value. You're using foam to get a good seal. Now, once this outlet has been sealed, whether you have children or not, you want to get the flat, and I'll show you, you want to get the flat child safeties, because what will happen is when you seal this up, there's these holes in the front that are going to still allow air to enter that box that we haven't insulated. So once that's all done, it creates a more airtight electrical box, especially throughout the home. That's going to add, you basically have about the size of a screw hole type hole that's leading right up into your attic space, which is, you put a bunch of those around the house, and they add up very quickly. It can get to the size of a business card or several business cards with all the outlets that are in your home. So let's get started. I'm going to shut the power down, and I'll show you how it's done. Okay, so unfortunately we're going to get some shadows here just because I'm using artificial light source. Now, once the power's off, you want to confirm that it's off. Now, you can use one of these, but a lot of electricians don't like them. Now, you'd get a beep. You'd obviously want to test at another circuit to make sure that this is working. So a lot of electricians don't like them because they can give false readings. The power can be on when they say that it's off, and they really don't like them. So they prefer that you use a multimeter. And this is, for your safety and just to confirm that the power is off. Now, I'm going to take the plate off. You can see I already have a gasket here that I used. But, this is a press and stick gasket that, seals everything up nice. But what you are going to see that I didn't do is I didn't seal around here. You can actually feel a draft from that outlet already. Now, use a Phillips head. Just take this off. And again, I already tried with the wand. It told me the power's off. I know this circuit. I know that there's no other like some old construction just uses, they use power. They use boxes to run through as like a junction box behind it. It's just not a good idea. I guess it's okay, but it's not the way I would do it. But so there can be other circuits in a box that is only supposed to have one. Now, you can see that this is the end of the circuit. I actually know that the electrical starts over there, and you would see another set of wires. The neutral's connected, and like I said, you just want to make sure. I'm going to turn this on. I've already tested it on another circuit. Now, you're not going to see it, but I mean, I just want to show you. So red to black, and I've confirmed that there is no power. I'll try another setting just to be sure. And again, hold on. Again, there's no power. So I was able to check that with this multimeter here, and now we can actually start doing some work on the circuit. Now remember, I wanted you to take a look at what's going on. So you just want to make sure that the screws are tight. Oh yeah, that one wasn't, that's not good. So I was able to get quite a bit of turn out of that. And this, they put the, looks like the wire behind on that plate there. So this looks good. The loop ends in the, so if I go clockwise, oh, that was a little loose too. So you know, we've just made sure that this, you know, this isn't going to arc. We would obviously want to check the other connections, any type of wire nuts, that they, you know, were good. And now that we've done that, we can start making sure that we can get a good seal. Just want to clean up around the outlet itself. You want to be careful of any wires. But okay. So what I'm doing is cleaning up around, making some space for the caulking to enter, because this the caulking is going to contract a little bit, especially over time. We just want to make sure that it has enough space. And that's it. That's that step to seal this up. So let's just get the caulking and we can start. Alright, so just to show you the multimeter and its function. This is your typical multimeter. You want to make sure that you can get a reading from a live circuit first. This one would be difficult just because the prongs are so tiny. And as you can see, I've bent that one. But you want to make sure that you can see that it is working first. And then once you've done that, you saw that I took the outlet out and I put them right to the screws where I would get voltage. Now, you want to first look for the wave that's fluctuating. This is a alternating current as opposed to a direct current. You can use the 200, 600. You just want to make sure that you're getting 120 volts. I mean, you might see one as low as 114. I've seen them, but you want to see that like 110, 120 to ensure that there's voltage. Now, once the circuit is off, you're just checking to make sure that there is, you know, 0 volts. And unfortunately, this is a little hard to show all at once, as you can see. But you can see no voltage. So that is how I know I can go and address the circuit. Now we've buttoned this up pretty good. We can get started on the gasket itself. Now I've already applied a gasket to this one. This was a press and seal one, or a stick and seal, and this is the company here. They come in a kit. So you're going to have your double, your decor, and what I'm looking for is this one, okay? And for your regular light switches, oh, that's for plumbing. So let's see, regular light switch. So I actually use these. I don't know if you can see it. There's a phone outlet over here. I'll actually use these on the back of the phone outlet because a lot of phone outlets, in my house at least, actually have an electrical box. And even if they don't, again, I want to seal all around to make sure no air is getting in that. And we'll adjust that in a little bit. Okay, now with the caulking, when I open a tube, I want to make sure that it's small. I don't want too much of that coming out. This is a fresh tube, so you just gotta be a little careful when we're... So I can actually see it in there. It's coming out. Alright, so now we're just going to move this out of the way. I'm going to start at the top where the biggest hole is. Just want to make sure that that really gets in there. And then start from the bottom here. And the reason I like doing this is it just kind of pushes it in. Should have took some sandpaper to this. It's a little messy. Want to make sure you get a good seal. Going over here. And then finally the bottom. Now this might seem like, wow, this is really easy. And it is. But I'm only doing one outlet. Remember, you got to go around and do your light switches. You're going to have to do your electrical outlet, and then of course your phone. Anything with an electrical box, you're just going to kind of want to take everything off and inspect it. So right now I'm just going to wipe it up, try and push it in to where it needs to be. Clean up any excess so you don't have to repaint. And we want to keep that out of the electrical box, and now we're going to let this dry. So at this point, after you've wiped it up, you want to make sure that there's no gaps, no holes, and then once it dries, it usually sucks in a bit, and you might have to apply more. So let's let that dry. Let me just take the camera here, give you a good close-up of what's going on. You can see that's sealed up real nice. So now no air is going to be able to enter here, and that gasket is really just going to have to, you know, it'll seal up any type of air loss from the front of the plate. And then after that, we'll add some child safety locks to make sure that, some child safety outlet covers, just to make sure that no air can get in there. And again, you do that whether or not you have kids. They're just pretty smart to have. And to help reduce that air loss, especially on exterior walls. If you take a camera, heat camera in the middle of the winter or the summer, you'll see where a lot of your heat loss is, and it really adds up, especially if you have a lot of outlets. So, all right, so we've given it about 20-30 minutes to let it set up. This stuff says it's paintable. You really really not ready for a couple hours, but I'm trying to get this done quickly. Now if you're doing it quickly, typically you won't just be doing one outlet, so you can do a whole room and then come back after the caulking is dry a bit, and that way if you ever have to take the outlet cover off, this stuff won't be sticking to the wall. Okay, so I've turned the power back on. Looks like I got a little crack there, but we're just going to check to make sure that the power is on and it is wired correctly, just in case we screwed anything up. If you see any faults, you'll know with this little device here. 2 lights, good to go. Now that that's done, these are flat. I like the flat ones as opposed to some that bubble out. These, I feel, do a better job stopping airflow from entering the outlet. And now that is how you seal up an outlet, electrical outlet. And everything else works similar, and we are good to go.